This is section 5, more advanced command line. In this section we will show you how you can install new programs or update your Linux system. We will then introduce you to the most essential basic networking concepts. Afterwards, we will give you an introduction to Linux services, the firewall, and how to troubleshoot your Linux system. We will end this section by showing you all there is to know about special file permissions in Linux. This is video 5.1, Basic Networking Concepts. In this video you will learn the foundations of networking in Linux. Just everything about networking is the classic domain of Unix and Linux, and in fact the old Unix folks do say that Unix has been created for network communication. Linux is considered one of the best systems to use, learn, test, play, diagnose and troubleshoot computer networks, because a lot of great tools are available in Linux for free and come right out of the box or just need a single command to install. There's a lot to learn about the subject of computer networks, and here we can only teach you the fundamentals of it using the CentOS 7 Linux operating system. Now let's learn about computer networks from a 10,000 foot view. The two most fundamental concepts in networking are the network or subnetwork and the IP address. The three most important facts every Linux user needs to know about them are the network, or sometimes called subnetwork, the IP address, and the rule of the same network. Rule number 1. The network. Every network, or sometimes called subnetwork, has a so-called network address, consisting of only numbers, and which looks like this. Rule number 2. The IP address. Every computer needs an IP address for communication, which is part of a subnetwork's address. In our example, the first three numbers, divided by dots, are the same between the IP addresses and the network address. Rule number 3. The same network. The most easy way for network communication between two or multiple computers is to connect them physically, for example using network cables and a simple switch, and then put them in the same network, which means to choose all of the computer's IP addresses from the same range from our subnetwork's network address. In our example, choose the 1002 as the first three digits for all our IP addresses. As you see, only the last digit is variable. Every computer who wants to talk to another computer in the same network then only needs the correct IP address of the recipient. This is also the basic setup of almost all private networks you may have at home. For example, this IP address here could be your personal private computer at home. This one here could be your network printer. This here could be your Xbox, and this here could be your wife's smartphone. As we have just learned, for normal network communication, all participants need to be in the same network. If this would be all there is to networking, we had to stop here, and modern communication and the World Wide Web would not be possible to exist. The reality is that there exists millions of networks connected together around the globe, such as our own private one, which are all connected through routers. If you want to communicate to another machine in your network, or any other network, your computer needs to have a so-called IP routing table, which defines static routes or the next hop towards a particular destination. This IP routing table is part of every Linux operating system. For example, if we have a private network consisting of three subnetworks with the following IP network addresses, if you want to get into contact with another computer in your subnetwork, your routing table could work the following way. If there is an entry in the table that defines what to do if someone wants to access the IP address of the 10.0.2.0 subnetwork, for example with the IP 10.0.2.15, for example, there exists a root entry in the table which defines that you should hop to the 10.0.2.0 network. The same happens if you want to access the machine with the IP address 192.168.1.22. Because there exists an entry in the table, the routing table will hop to the 192.168.1.0 network, where this computer is part of. For all the other IP addresses where there is no explicit rule, the so-called default route will be used. In most private networks, the default route is the IP address of a real hardware router, which basically is the same as an IP routing table, but can do more, as it is connected to other routers around the globe, where it will find its way to the correct destination address. This is also called dynamic routing, as the route or path between a source and a destination can vary, dependent on which routers it will use. Normally, each private network most internet service providers offer have only one public IP address, which connects to the public internet. All machines from our private network need to go over this router with its single public IP address if they want to communicate with other computers in the public internet. On the other hand, if an outside public machine from the internet wants to access the private computers from our subnetwork, the router needs to take care of the correct delivery of messages to the right recipient, which has an internal IP address only visible within our private network. But how can you define an IP address for a computer? The IP address needs to be set on an OS level in the correct configuration location associated to a certain network interface. But as said before, the IP addresses need to be unique in the same subnetwork, otherwise the correct recipient for a network message cannot be found. So how can you take care of that? First approach is to manually manage a list of computers and all free and reserved IP addresses available in this network. Here we need to assign static IP addresses, which means every computer gets an IP address hard-coded into the system, which will not change and remain stable. Often important services in networks, such as a mail or web server, have a static IP, because they must be reachable under the same address all the time from multiple other computers or services. But as you can imagine, this system is very inflexible and needs manual intervention all the time. Just think about a public wireless hotspot and all the people who are connecting to this network all the time with multiple devices such as smartphones, laptops, tablets, etc. A much better solution is to use a so-called DHCP server, which is a service running in your network which listens to, new and keeps a database of all devices currently connected to the network and automatically assigns or revoke and manage IP addresses to all the machines connected very reliable. The IP addresses assigned to the computers are dynamic, which means tomorrow your computer can have another IP address than today. The great thing about this system is that it can also send additional information about your network to the computers connected. For example, the IP address of a private DNS or mail server in your network. A DNS server is another very important networking feature we need to know. As we have just learned, computers communicate with each other using IP addresses only, which are just numbers. As we humans are not so good in memorizing or recalling long sequences of numbers, but are much better working with names for objects or things, a system has been developed to assign names or aliases to these IP addresses, so we can address computers by names instead. A DNS server now has a database which stores these relationships. As computers can only work with numbers and not names on the network, every time we want to connect a computer using a name, a corresponding DNS server gets asked internally to translate the name to its corresponding IP address so we can make the right connection with the IP address instead. Now for resolving names of the normal internet, such as google.com, we will use some public DNS servers normally provided by your internet service provider or from another source. But how can we give names to our internal private computers' IP addresses in our subnetwork, because the public DNS servers don't have this information? One solution would be to install and set up our own private DNS server and add new names to IP address relationships. As this needs a lot of work to install and configure, a more easy and fast solution is to put the name to IP address relationship locally in a special file called /etc/hosts file. The biggest disadvantage of using the hosts file is that you have to put this file on every single computer in your network who wants to resolve network names, and also you have to keep this file up to date all the time, so each time a new computer is added to the network, every computer in the network needs to update their hosts file. Until now we have only spoken of names to IP address relationships when it comes to DNS servers and the hosts file. But here we need to discuss the anatomy of such a name even more. For example, you could give all the computers in your network host names of the persons working with them. So the IP address ending with 15 could be Carl, the IP address ending with 16 could be Jane, the IP address ending with 17 could be John, and the IP address ending with 18 could be Paul. But you can also use any other name schema you like. But as you can imagine, these host names are not unique enough to fully qualify a computer in a network, so that we can directly address it. Just think about that our private network can consist of several different subnetworks. For example, one for the IT department and one for the human resources department, and so on. Now here two people can easily exist with the same name in different subnetworks. So this would not work, because the computer host name Carl exists in both networks. And we just cannot use the host name alone to differentiate unique computer names. Therefore, we can also give names to subnetworks or network addresses. This kind of name is also called the DNS name or domain name. The host name or name of the computer plus the DNS name combined together, separated by a dot, is called the fully qualified domain name, or short FQDN, and really is needed each time we need to access computers in different networks outside our own local subnetwork. So here, using the fully qualified name to address Carl in the itdepartment.com will not clash with the Carl in the humanresources.com subnetwork. In summary, a host name is a computer name, for example Carl. The DNS name is the name of a network or subnetwork like mycompany.com or google.com, and the fully qualified domain name is the host name plus the DNS name separated by a dot, for example carl.mycompany.com or mail.google.com.